Ladies and gentlemen, boys and girls, welcome back, Master Algebra. I'm Mr. White. This is lesson 6-1, solving systems by graphing. On problem number 1, we're going to solve a system of equations by graphing. We need to figure out what is the solution of a system. What we can do is we can take our two equations, and if we graph both of them, we have the first one, we'll call this A, and we have the second one, we'll call this B. Okay. They are both in y-intercept form, slope-intercept form. So if we take the first one, A, if we go to a y-intercept of 2, we're going to go up to 2 and graph our point. If we now go up 1 over 1, up 1 over 1, and up 1, right 1, put a point, we have a nice graph. If we take the B equation and we go down 2, and then we go up 3, 1, 2, 3, and then right 1, and then up 3, 1, 2, 3, right 1, you will see that we get this line. So if you're wondering, how does graphing each equation help you find a solution? Well, a line represents all the solutions of one linear equation. So the intersection of two or more lines is a solution to both equations. Well, if we look at our A and B, they both intersect right here at this point, which is over 2 and up 1, 2, 3, 4. So we have a solution at 2, 4. Okay. If we need to check, just to make sure, if we take this point and plug it in for x and y here, and plug it in for this one, x and y. So we take our y equals x plus 2. We plug in 4 for y, 2. 4 should equal 2 plus 2, which is 4. So we know it is we know that that point is on the A equation. If we take the next one, B, y equals 3x minus 2, we plug in 4, and we get 3 times 2 minus 2. 4 should equal 6 minus 2, which is true. So the point 2, 4 is on both equations. Therefore, it is a solution to the system. Okay. Got it. What is the solution of the system? Use the graph to the right. Go ahead, hit pause. Graph the system, find the intersection, and then check your answer. Go. Welcome back. If you notice, by graphing both equations, you should have an intersection at -2, 0. If we check, make sure you do show that check. We get 0 equal to 0 and 0 equal to 0. So yes, -2, 0 is a solution. Okay. Problem 2. Real life, real world. Biology example. Scientists studied the weights of 2 alligators over a period of 12 months. The initial weight and the growth rate of each alligator are shown below. So after how many months did the alligators weigh the same amount? So what we're trying to figure out is we have a linear rate for alligator 1 and we have another linear rate for alligator 2. We need to figure out where they equal. So what we could do first is we're going to set up equations. We're going to we have a y-axis and an x-axis. We need to figure out, well, what are we doing? Well, we have an initial weight of 4 pounds for alligator 1, and then we have that change of rate, or rate of growth, which is really our slope of 1.5, and we have a slope of 1. So if we let W equal the alligator's weight, we can also let T equal the time in months that we're going to look for. And again, the thing that's changing that rate of growth, we'll call that the x that's being applied as time goes on. So this is our x, and then W is really our y. So if we look at alligator 1 and alligator 2, we can write two equations. For alligator 1, we know that the weight that we're interested in starts with, so this alligator starts with an initial weight of 4 pounds, and then per month, as the months go on, it gains 1.5 pounds. So we're going to add 1.5 T. With alligator 2, we have the initial 6 pounds plus 1 pound per month from there. So what we need to do is we need to graph these two equations. Okay. Well, to make it a little easier, if we take and call this alligator 1, alligator 2, we'll use our input T, and then out comes W, input T, out comes W. We can just use our x-axes, or in this case our T, for 0, 1, 2, 3, 4, or a few points to help us draw the graph, and then do the same thing with both alligators. So if we always choose 0, 0, and then we can choose, let's do 1, 2, 3, 4, 1, 2, 3, 4. Okay. Go ahead, hit pause real quick. Plug in those numbers for both alligators. Graph the equations. I'll see you back here in a few minutes. Go. Welcome back. If you notice on the left here, we had the blue, or alligator 1, okay, and then on the right we had the red, or alligator 2. By plugging in 0, 1, 2, 3, 4, we got some points 4, 5.5, 7, 8.5, and 10 for alligator 1. And we had 0, 6, 1, 7, 2, 8, 3, 9, and 4, 10. If you notice right here, and we could have kept going to help us if we needed to, at this point, 4, 10, which is on both graphs, or the intersection of both graphs, or lines, is 410. So answering the question where it says, after how many months did the alligators weigh the same? We know, based on the 4, which is T, months, and then we'd have W in pounds, we could say, after 4 months, both alligators will weigh 10 pounds. Next page. A system of equations that has at least one solution is consistent. A consistent system can either be independent or dependent. Again, what we're saying is, if I have this graph and we have 2 lines, so let's say one was this way and one was this way. We have an intersection there. If we have that one solution, we say that that's consistent. If a system has no solutions, we say it's inconsistent. Well, if you think, how can we get something that has no intersection? Ding, 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 ding. Some of you thinking, if we have parallel lines. So if we have parallel lines, these 2 lines will never intersect, so we call that inconsistent. Okay? Go back for a second. Now, if we have a consistent or a solution, it really can be broken up into 2 things. We have that independent or dependent. A consistent system that is independent has exactly one solution. Case in point, this one in red, which I'm circling. Okay? That has one solution, so it's consistent and independent. Something that is consistent and dependent, what's going to happen is, we're just going to get one line, and then that other line is going to be right on top of it, which basically is saying it's the same line. So if we have 2 equations that have the same slope and the same y-intercept, we call that dependent, or infinitely many solutions. So what we want to do on problem 3, we're going to look at infinitely many solutions or no solution. What you need to do, we're going to hit pause in a second. You're going to graph A and B, and then you're going to tell me, is it consistent or inconsistent? And then if it's consistent, tell me if it's dependent or independent. Okay? So again, graph the equations, tell me if there's a solution. Go. All right, welcome back. If you notice, A, we only had one line, And the reason why we had line is if you solve for y on the top equation, you get the same answer as the one underneath it. So we have two of the same equations, which means you have two lines that overlap each other. So do they have a solution? Yes. So we call that consistent. And now, do they have one solution or many solutions? We know it's many solutions, so this has infinitely many solutions. So therefore we say it's dependent. On B, we had two different equations. They have the same slope, two different y-intercepts. Therefore, we have parallel lines. We have parallel lines. Parallel lines do not intersect, so they will not have a solution. So we have no solution. Therefore, this is inconsistent. All right. Let's check again. Let's call it a 200-point quiz. 100 points for A, 100 points for B. So on 3, what is the solution of each system in parts A and B? Use that graph. Describe the number of solutions. Tell me, is it consistent or inconsistent? And if it's consistent, tell me if it's independent or dependent. Hit pause and go. Alright, welcome back. 3A. Notice they're both solved for y. They have the same slope, different y-intercepts. Same slope is going to tell you different y-intercepts, parallel lines. So therefore it's inconsistent, no solution. We have no intersection. B, if you have to solve for the bottom equation by dividing by 3 all 3 times. And you get y equals 3x minus 3, which is the same equation as the top. Therefore we have multiple intersections. We have infinitely many solutions. And therefore it is consistent and dependent. Before graphing the equations, so if we can look at our equations before we even graph, how can we determine whether a system of equations has exactly one solution, infinitely many solutions, or no solution? Okay. The biggest thing we need to look at, remember, is the slopes. Because if the slopes are the same and y-intercepts are different, we have parallel lines. And we have to say to ourselves, no, they're never going to cross. So therefore, those are inconsistent. Okay, same rationale. So, systems with one solution have lines with different slopes. And therefore, they're going to intersect. Systems with no solutions have the same slope but different y-intercepts. And systems with infinitely many solutions have the same slope and the same y-intercept. All that before you even graph it. Then we want to graph it and check. So go ahead and hit pause for a little bit. You're going to finish up practice graphing systems practice number 1. Be sure to check your answers here on the video. Okay. And when you're ready for your mastery quiz. Go ahead and hit pause. Hey, welcome back, some of you fast forward kings. Let's see how you did. Here, 1, 2, and 3. Okay. Make sure you check. It is part of the answer. Okay, so we got -2, 3, 3, 1 in the middle, and no solution. Therefore, you don't really have to check because they're not going to be on each answer. 4 and 5, we got 4, -2, and infinitely many solutions. Okay, don't have to check that. If we were practicing what we were doing beforehand, if we have infinitely many solutions, you know that these are consistent and dependent. We know that number 4 was just consistent and independent with 1 point. Go back up. Number 3 with the no solution, that was inconsistent. Number 2, consistent because it has a solution. And again, it's only 1, so you are independent. And number 1 did have 1 solution, so again, it's consistent and independent. Hey, congratulations! We'll see you next time. Remember, do your best, forget the rest. Bye for now. 4. Got it.